Hi everybody, this is the second part of experiment number 3. So here we have a cylinder of a metal B, and we immerse that for 10 minutes in hot or boiling water actually. So the temperature of this boiling water, let's just check. So we can have the exact number. So this thermometer says we have 99.5 Celsius. So that's the temperature of the boiling water. We keep this immersed, as I mentioned, for 10 minutes. So the temperature of the metal is 99.5 Celsius. Here in the calorimeter, we have about 150 milliliters of water. I will provide to you the mass of the water that we have in there. And again, we have the temperature probe connected to the data logger to collect the temperature versus time data. So the temperature inside the water inside the calorimeter is about 19.4 Celsius. So what we're going to do now is we're going to remove this from the boiling water. So be very careful if you do this experiment in the future, if this is really hot. We're just going to quickly remove any excess of water that we have here. And we're going to open this, put our cylinder in, close it, and then just turn this off. And then we're going to start stirring. I'm just holding this to assure that our calorimeter is closed, since we have this piece of wire out here. So as you can see in the data logger, the temperature of the water inside the calorimeter went up to about 26.8 Celsius. I will provide this data for you as well. So when we are measuring the heat capacity of these different metals, the experimental setup is the same. We use boiling water to heat up the cylinder of the metal. So the temperature of the metal, we expect it to be the same than the temperature of the boiling water, which is 99.5 Celsius according to the thermometer. After that, we immerse that cylinder in a known mass of water at room temperature. In this case, it was about 19 Celsius. And we collect the data for about 3-4 minutes. So for all the metals that we have in this experiment, we have metal A, metal B is the one that is inside the calorimeter right now. This is metal C, this is metal D, and this is metal E. So we are going to find the heat capacity of all these metals. I will provide all the data for all of them, so you can calculate that heat capacity. And if you have the heat capacity, then you can identify the metal. Another important thing is that before you start the experiment, you have to measure the mass of each metal, because to calculate the heat capacity, you will need mass of the metal and the delta T, which we will calculate based on our data over here.